Okay, let's take a look at some additional examples. Lesson 3 examples continued. I'm going to focus here on the trigonometric functions. Example number 8. Y equals the cosine of 5x cubed. Say that differently. Y equals the cosine of stuff. Y equals the cosine of stuff. What is the derivative of the cosine of stuff? Negative sine of stuff. So let's do it. dy dx equals, the derivative of cosine stuff is negative sine of stuff. And then the chain rule requires that I take the derivative of the stuff, and that will be 15x squared. Example number 9. Y equals the sine of 5x plus 2 times the secant of 6x squared plus 1. You will see shortly that committing the derivatives to memory, the trig derivatives to memory, is absolutely essential so that you don't get lost in the details of the chain rule by trying to scourge around for the derivatives of these known trigs. You should have them committed to memory. Here we go. dy dx equals, well, the overarching property would be product rule. So I will write the first term. Now I will multiply by the derivative of the second. You need to say this to yourself. You don't need to, but I think it really helps to say it to yourself. Secant of stuff. What is the derivative of secant of stuff? The derivative is going to be secant stuff times tangent stuff. This doesn't change because I started with stuff. I have to write the same stuff. Secant stuff, tangent stuff. Now I have to multiply that by the derivative of the stuff, 12x. Next, it's plus the second term. Multiply that by the derivative of the first, which will be cosine of stuff times the derivative of that stuff. That completes number 9. Here we go. This is a tricky one. The notation really trips people up, and I don't think you will always have to do this, but while you're still at the beginning, it behooves you to write the tangent of 4x and then write all of that to the power of 3. I think that will help you to organize your work. So here we go. F prime of x. Well, we have a lot of stuff, or we'll call it big stuff, to the power of 3. So the derivative of big stuff to the power of 3 is 3. Big stuff to the power of 2. Take a deep breath, because now we're going to find the derivative of the big stuff, and when I find the derivative of the big stuff, I can call that tangent of little stuff. What is the derivative of tangent of little stuff? Secant squared of little stuff times the derivative of the little stuff. Okay, this was an f of g of h of x problem. Pretty fun, huh? Example number 11. I would like you to try this one. You're going to find dy dx. In a moment, you're going to press pause. Keep in mind, for some reason, this one really trips people out. Let's see if you can get it right, and then we'll talk about it. Press pause now. Okay, hopefully you tried this, so let's reveal the solution. I'm going to write this as the secant of 5x cubed minus 2x. I'm going to raise the entire thing to the power of 2. Now I'm ready to find that derivative. So it's going to be 2 stuff. I'm maintaining these brackets for my organization. As you become more comfortable, you don't need this bracket. In fact, I could say 2 stuff. I could even put the 1 here to help me realize that that was 2 stuff reduced the power by 1. So it's to the power of 1. Now I have to do the derivative of the stuff, secant of some little stuff, which is going to be secant of the little stuff, tangent of the little stuff, And then I know I have to do the derivative of the little stuff. Make sure I have parentheses, 15x squared minus 2. Now what makes this tricky? Well, if you don't do the organization, and you don't write this one, and you don't put the bracket, then sometimes people will write secant. And then when they find the derivative of that and say secant tangent, they think, wait, I just wrote secant, and so they don't write it a second time. This bracket together with the 1 helps us to organize so that we can recoup to then move on with the problem. Example number 12. Holy cow, this is a tricky one. It's actually kind of long too. So let's see if you can do it. In a moment, press pause and then work out the solution. We're going to find dy dx. I went way over to the left because I think this is going to take up a lot of space. Press pause now. Alright, I'm going to work it out. 1/3 stuff. Oh, it takes 20 minutes just to write the stuff. Kind of a pain in the neck. To the power of negative 2/3. Now I'm ready to do the derivative of the stuff. We have two parts to that. Part 1, part 2. Part 1 is going to be 2 cosecant of 5x minus 2 to the power of 1. 2 stuff to the power of 1. Now I have to multiply by the derivative of cosecant 5x minus 2, which is negative cosecant 5x minus 2 times cotangent 5x minus 2, and then times 5. I put an extra set of parentheses here because I didn't want you to think that this here represented a minus. It represents a negative. I certainly could have brought that out here to make it easier, but in the nature of keeping things unsimplified, that's how I decided to write it. I'm still inside this bracket though. This portion here completed the derivative of this, but I can't forget that I have to do the derivative of this, and that derivative is 1, and then I close off my bracket. Or of course that could have been a parenthesis. I'm going to have you try 13 on your own too. Y equals sine cubed x times tangent 4x. Press pause now. And here is the solution. I've put in that peach color, the kind of tricky part. We had the first term, derivative of the second, secant squared 4x, times derivative of stuff, 4. Then we had plus the second term. And then the derivative of the first, which is circled in this peach color, meant I had to do the derivative of this, which is then 3 stuff to the power of 2 times the derivative of its stuff, which is cosine x. This will be the last example on the page. Y equals 2x times the square root of secant x. Give this one a try. Press pause now. Guess I'll walk us through it. I'm going to circle this to make it the secant of x to the 1/2 power. Okay, here we go. First term times the derivative of the second, 1/2 secant of x to the negative 1/2 power times the derivative of secant of x, which is secant x tan x, plus the second term times the derivative of the first. Boom. There we go. You might notice that I interchange these. At one point over here I wrote it to the negative 1/2, and then back over here I put a radical. That's okay to interchange them. I want to make sure that the pieces are there and that everything is correct. So don't worry about interchanging. You certainly could have written this piece here as the secant of x to the 1/2 power.